Good morning, folks. Welcome to Sql Join and Union class. This is the last class for Sql. I actually thought that it would take me 6 sessions to cover this. That's how it's done in the other training center. But I was surprised that I was able to put all this in 3 classes. So guys, y'all are looking at starting Java from next week. and and then it's just it goes really fast, and you're almost done. So um,
Cool. Sounds good to me.
when we get to Selenium class, I know that I can do 2 classes a week. In
Mm-hmm.
Java, I cannot promise that I can give you 2 classes, but I'll try my best. Mainly because I have not designed the material for Java. This is going to be done out of scratch. And since I'm working during the weekday and super busy with stuff, Saturday is the only day that I have to plan this out. And technically, it takes 2 hours to design a 1 hour presentation. So I find myself working full time on Saturday, the entire day, to design the lesson and the delivery ways for you all. Now, it takes me quite a while to filter too much reading for your end, so that I only have the basics that you need, and focus your attention in a certain way so that you can understand this better. So that takes a lot of thoughts. Anyway, but good thing is that because I do that, your materials and your classes, the number of classes are much less. And I believe that I'll be able to do the same thing for Java. And I know the training centers take a month and a half to just do the Java, sometimes 2 months. They say that it's 4 months program, but it ends up in a 5.5 months program. Um, so anyway, I feel that when I put my hands on Java, I should be able to walk you down that road in much shorter time. And the fact that you guys are very selective ones. Um, uh, I mean, in my class group in training center, you all 4 of you would be like the top students. And I taught many students from different spectrum, and I've seen even the weakest one become very successful because they really want it and they work very hard and they ask a lot of questions, and they stay in they come to classes, they attend the classes, they go home and practice because they really want to change their lives. So with that energy, I've seen a, a lot of students that are uh, half as much as smart and intelligent than you are, but being able to do very well. So you guys, I think I can walk you through Java and Selenium pretty fast. So I'm pretty excited about it. Anyway, with that, next weekend, uh, we're gonna do 2 classes, okay? But one is gonna be self-study. So your first class is going to be a video, and the video is going to be on how to download Java into your computer. And I have I have the video from um, the previous classes that I've done, but I can't give it to you yet because you saw what happened in downloading MySQL is things kind of change. So I need to walk through that video and make sure that the download process is it still the same or not. If it's not, then I'm going to have to create a separate video and then give that to you. But I'll give that to you before Saturday. So Saturday, your assignment is going to be watch that video independently and follow the steps, download the Java into your system, and shoot me a text saying that you've done it, or let me know if you got stuck on something. And I will probably set up something on the spot with you on Saturday and then troubleshoot, try to get things going for you. Because Sunday's class, uh, that's going to be when we use the software to actually start working on the Java. And that, I don't know how many days that's going to take, but again, crossing fingers, is going to be a lot less. And once we get the Java concepts down, we move into Selenium, and from day one you're going to see an automation happening with that code and the software that you're going to download. But anyway, details is going to be provided in that video. So just look out for my text. Once I have that video posted, I'll send you all a text letting you know that it's there, and you can go from there. Just a couple of things before we get started is on the videos. Have any of you been watching the videos? I need to know how the quality is. Can somebody give me a feedback on this?
Yeah, the quality is pretty good. Whenever I forget something that is pertaining to homework, I kind of go back in your videos and look at the part when we went over it.
Mhm.
And the sound quality is pretty good. Obviously, video quality is fine. But yeah, the sound quality is, I mean, it's normal. I didn't think anything of it. So it's okay for me.
All right. I have two versions here for SQL insert, update, and delete. This one is just a standard Google Docs version, and I've been using just the Google Docs video for that. And this particular one is for YouTube version. Um, when you get a chance, if you look at it, give me a feedback if you feel strongly about one or the other. I felt like the video resolution is better with YouTube, but I could be wrong from the other end. I've also experimented with this monitor that I have right now. The previous monitor was a widescreen, and that was capturing not so great. You may have also experienced when you open up the video that it doesn't cover the entire screen. It only covers certain percent of the screen. So I didn't like that. But um, hopefully this particular one is going to be the whole thing, and the sound quality is going to be pretty good as well because I added an external mic. I don't know if you can feel the difference in the sound for this today's meeting.
I just wanted to say that I tried to watch the YouTube version and I click on it, and this was it was a couple days ago, and it said that your channel was private, so I couldn't watch the videos.
Okay, yeah, I forgot to set that property to public,
Okay.
and now it's set, but I also took some of those off. I think I converted them to Google Docs. But if you find any of those videos not working for you, send me a text so I can go right away and change things. But looks
Okay.
like Google Doc might just work out fine instead of YouTube. But I
Okay.
prefer Google Doc. If you think that YouTube version is much cleaner, crisper, then I'm not going to use YouTube, but there's a paid version. It's called a Vimeo. So
Hmm.
I'm going to create an account with them and then have videos uploaded through them because we need quality videos for you all to watch. So
Yeah. Next time I'll try the docs version and I'll let you know. It should be fine. I just know when I clicked on the lesson, it only took me to YouTube, unless I messed it up. I don't know. But so yeah, I'll for sure try that next time. I don't think I'll have an issue with that. So
sure, thanks. I'm going to post today's video into both Google Docs and YouTube, and y'all can give me feedbacks on that. I think the screen setup is going to work out much better than my widescreen monitor. So fingers crossed. All right. let's get started. So for database, join and union is our last class. And let's see what we're going to cover today. Today's class is going to cover SQL statement called join. We're also going to look at something called union. They are kind of sort of same. We're also going to briefly look at creating tables, go over what does DDL, DML, DCL, and TCL mean, and explain the homework to you. So with having said that, let's go to the next slide here. Take a look at a scenario. Suppose you have a table, which you've seen in W3 School. This is a snippet from the orders table. So suppose you have an orders table, and then you have customers table, and you have two types of data in, I shouldn't say types, but different data, different kind of data presented in these two tables. Who can tell me if there is one particular column in both of these tables are the same?
Customer ID.
Correct. Notice that customer ID in orders table, which is right here. Let me see if I can get the pointer. So customer ID in the orders table is exactly same as customer ID in customers table. Now, it does not have to say customer ID in both tables to be the same. It could still be same. This data, this number 2, I could call it customer ID. I could also call customer number in another table, but essentially they could be exactly same thing. Does that make sense? It's how, as a database administrator, I want to design it. If I want to call it customer number in customers table, but I know that that's the same thing as customer ID in orders table, then you essentially got the same data in two different tables with two different column names, which is totally fine, but they would still mean the same thing. For example, this number 2 right here, customer ID, is the same as this particular customer that they're referring to, who is Anna right here. And she may have this order ID right here and the date and stuff like that. Now, sometimes you may need a table, you may need to display a table that has a mix of these two tables or multiple tables. For example, take a look at this table. This table is a mix of the orders and a customers table. First, you got the order ID from orders table displayed. Okay. Next, you got the customer name displayed in this new table that you want. All right. And then you got the order date from orders table and displayed in this particular table. The reason you may need a mix of columns and create a new table to display, this is heavily used in the corporate world for various data analysis and decision making, or even assigning work. For example, you may need this particular table to give it to your shipping department and tell them with this particular table that these are the customers and these are the orders that they placed on that particular date. So you need to ship these things or whatever the work that they have to do. So as a database administrator, you may get a lot of requests for different types of data displayed in a certain way, in a very refined way, and then you may need to print this out and give it to somebody, and that department might take that and start working, going about their lives. Any questions on that idea?
Nope.
Okay, so with that idea, now what happens is if you have a the way you're going to create this is the keyword called join. And what join does, there's many ways to do joins, but one of the common ways is it takes a customer ID from one, or a common data from one table, and matches with the common data in another table, and that's how it will take the common ones and report in the table, or the new table that you want to display. For example, this customer ID here in orders table matches the customer ID, which is number 2 in customers table, and this record is related to this record, and therefore certain things you wanted to display and only got displayed that has the matching ones. Same thing, number 37 customer ID is going to look for number 37 in customers table, probably going to be way down here. And then whatever the name is, we'll take that particular name and display it on this new table. And 77, same way. Do you see the flow?
Yes.
Okay, so that's basically in a nutshell what's going to happen. Now I'm going to walk you through how to get that done. So first thing, let's talk about what is Sql Join. Sql Join combines rows of 2 or more tables. So there are 2 things that you need to know. One, it's going to combine the rows from 2 or more tables. We're going to start with 2 tables, and I might have an example for 3 tables, but there is no limit to how many tables you want to join it. Nothing fancy about the word join. You're just connecting them. So that's what it means. Now, for you to join 2 or more tables, you have to have a matching column between them, or based on related column between them. You have to find one column that you feel, or that you find, or you know that they are matching, or they are essentially the same, like the customer ID that we had in the previous example. Now, there are several types of Sql join. The most important and most used one is called the inner join. Right? In the inner join, what you have is you have 2 tables, table 1 and table 2. And just like it says inner, I want you to think about this image. What's happening is you got a lot of data in table 1 and a lot of records in table 2. But when you do inner join, it only takes the data that's common between the 2 tables. It's only going to display that part, the matching data, matching records for table 1 and table 2. Left join, and these are SQL commands that we're going to be using. So inner join and left join. Left join is going to take everything, all the data that's in table 1, and only the matching ones from table 2, and display it to you. Now, if you flip this idea of left join, what you have is the right join. Right join is the same thing, just the opposite of left join, where it's going to display all the records from table 2 plus any record that matching column from table 1. Okay, we'll see that in a second. And the last one is full outer join, and it's going to display everything that's on one table, and it's going to display everything that's in table 2. Also, it's going to display everything that's matching. All right. Now, unfortunately for W3 schools, I haven't been able to work the right join and full outer join in the executor. I don't think it supports it. It will support it in MySQL that you downloaded, but we don't really need it. Right join can be done with left join. All we have to do is flip the tables. So that works there. And outer join, we can get by with using union, and you will see how that works out. So mainly we're going to need inner join, left join, and right join and full outer join. You just need to know the concept if you get an interview question. But other than that, you really don't need examples to go over. Any questions on this concept before we move on to a practical work?
No.
All right. So what you have is, first, let's look at inner join. Inner join is going to select records with matching values in both tables. Okay, so it's not going to display everything from table 1, and it's not going to display everything from table 2, just the matching ones. Here's the syntax, and we got same old select, and then we list our column names. We have the same old from, and then we mention which table. And what you mention here, the table that name that you're going to list here after the from, becomes the table 1. Okay, always the table 1. Then you cast this command called inner join, and then you list the name of table 2. With inner join comes another word. It's a must. You have to use on, meaning right after the on, you have to say on which column. Which column do you see that they are matching? What do you want to inner join on? So that's where this on comes in. And then you list which columns. Now, there's a particular way that you have to list this. You have to specify which table, because there are two tables, table 1 and table 2. You got a table 1, and you have to specify which column in table 1 with the equal sign saying that it matches, or you're matching it. With table 2 and a certain column, you put a dot between them. So table 1 dot, what's the column name that matches? Which was customer ID, if you remember from the other example. And then table 2 dot, which column? Okay. Now, generally, these column names are going to be the same. Okay, like customer ID and customer ID. So that's a little trick for you to remember, that these two parts are always going to be the same. I shouldn't say always, 99% of the time. Now, if somebody names customer ID in one column, one table, and customer number in another table, but they are essentially the same data, yeah, I can see that changing a bit. And that's okay. You can change that. And obviously, you're always going to have two different tables right here, table 1 and table 2. And here's a little trick. Whatever you list after the from, which is table 1, is going to be listed right here. Okay. And whatever you list as inner join table 2, you just name it right here. So those things you can do by closing your eyes and just bring it down, bring that down, and then which two columns or which particular column that you thought was matching. All right. Any questions about the syntax? Let's take a look at a real example. So here's one question. Hold on one second, please. All right, we'll do this slide and take 5 minutes break. So display order ID and customer name for matching order IDs. So that, see that matching order IDs. So that's where I have to match from customers and orders table. Matching order IDs. I don't know if this is a, let's see. All right, so let's split the screen here. Something about the order ID seems a bit weird. Hold on. Okay. Can you see things all right?
Yeah, we can see.
Okay, great. Let me know if I need to zoom in to increase the visual a bit. All right. So we got display order ID and customer name for matching order IDs from customers and orders table. So let's take a look at customers table. So we got this customers table and we have customer ID here. We don't see anything else. Let's see where we can find display order ID. So if I go to orders table, I got the order ID here. Do you notice that this table also has customer ID in here?
Yeah.
So let's take a look at customers table. We got this customer ID. And then if I go to orders table, we still have the matching customer ID. If you don't find something matching, you won't be able to create a join. So your first step is select records with matching values in both tables. So you got to find, what are we going to match it with? So now that we saw the customers table, we got customer ID, and orders table, we got customer ID. We know we can match it with that. Okay. Next thing, what do we need to display? All right. It says display order ID. So it wants you to display the order ID from here. And customer name, it wants you to display the customer name, which is from the customers table right here. Okay. That's it. So let's handle this, okay? And we got to match them. So whichever it's matching for them, and that's going to be your inner join, because it didn't tell me display everything. It just says matching. So we're going to match the customer IDs with those two tables. Let's take a look at what if I wanted to display everything. Okay, somebody give me the query to display everything. What's the first part?
Select star.
Select star. Okay, step by step. Good. So if I do select star, nothing changed. What's my next thing after the select star? What do we do?
From whatever table you need it from.
From whatever table. In this case, how many tables are we dealing with?
2 tables.
2 tables. So first, you name any table that you want to. Honestly, it's up to you which one you want to call table 1 and which one you want to call table 2. There's the sequence doesn't matter. Okay?
Oh.
Doesn't matter. But you got to do this. I don't think you can go wrong. So forget it. Just tell me which table you want me to write first.
Customers.
Okay. So if you want to go with customers, all right, I got my one table down. Now, generally, if you put a semicolon and hit run SQL, it's going to give you all of these. Yes?
Yeah.
Okay. But we don't want that. But we want to join it, right? Now, next step, because you want to join this table with another table, this is where you put in your join command. So you have to write inner join. Okay. Now you have to mention with which table. You got the customers. Now comes your second table. Again, the order doesn't matter. but you don't want to say customer
Order.
again. Yeah, you don't want to repeat the name of the same table. Therefore, the second table that we had was orders. You go ahead and write down the name of the second table. With me so far?
Mm-hmm. Yep.
Okay. Next, now you have to say on what? On which matching column? Okay. So if you would have to put this on command, and then you have to specify which column in this customers table are you trying to match with which column in this particular table. All right. So first thing you want to do, if you want to follow a pattern, then you just take this first table name, copy that, put it right here. With me?
Mm-hmm.
Mm-hmm.
And what's the name of the column that we're trying to?
Customer ID.
Customer ID. You put a dot, and then you write customer ID. With me?
Yep.
Mm-hmm.
And then you say that column of this table, I'm trying to match it with, meaning an equal sign, match it with. Then it's your second table. Just close your eyes and take that. Bring it here. And if you go to orders table, we notice that orders table also has the customer ID. Yes?
Yep.
And then you write customer ID there, semicolon to close, and you're done. Questions so far on this setup?
No.
All right. You notice that that first table is the same thing as the first one I wrote here. That second table is the same thing as second one I wrote here after the equal sign. And then notice, like I told you, this last part after the dot is always going to, 99% of the time, is going to be the same. If you have it something different and you get an error, I want you to come in and check here, because you may have put something in a wrong way. Let's go ahead and hit the execution and see what we get here. Now, notice that, let me do the whole thing here, full screen. Notice customers have 92 records. Okay. And orders, order table has 196 records. Okay. And when we did the search, it gave me 195 records. What does that mean?
That one didn't match.
One from one of these tables, and most likely the orders table, didn't match. And therefore it didn't display in here. What do you notice about, there's too many records here. What you want to do is lower it down to maybe 5 records just to get a feel for the columns. Who can tell me how do I reduce it down to 5? 5 rows only.
Just five records.
Yeah, 5 records.
Could you do the limit?
Limit 5. And then if I search that, now I have 5 records. Notice I have a scroll bar.
Yep.
Do you see these extra columns here? Customer table never had these columns.
Yeah.
Remember? These columns are coming from where?
From orders.
From orders. Because you have specified all columns with that star, it interjoined those two tables and also displayed every single column that was there. All columns from customer table and all columns from orders table. Understand?
Yep.
Let's go back to our question, and that was, display order ID and customer name only. So let's take a look at this. Now that we got this, and this is how I want you to do it this way. First, join the tables. Don't worry about too much ornamenting, and then you go details, and then you clean things up. All right. So right here in this star section, I am now going to specify which columns my question is asking me. One is order ID, okay?
Okay.
And the other is customer name. Now, order ID comes out of which table?
From the orders table.
From the orders table, right here.
Mm-hmm.
And customer ID comes out of customer name comes out of customer table. Agree?
Yep.
If you just write customer name and order ID, SQL might panic. He doesn't really know because you're joining two tables. He might get confused.
Okay.
You have to specify which table and which column you want.
Okay.
But the first one that you specify here is going to be the first column that's going to be displayed. Okay. Our question says display order ID. I know the order ID is in orders table, so you have to write the name orders table first, and then put a dot, and then say order ID. Yes?
Okay. Yeah.
It's orders. Now put a comma. You needed another column. You don't need all columns, but another column. You need a customer name, and that comes out of customers table. So you have to specify SQL that it's going to come out of customers table dot customer name. Any question?
Nope.
And now if I do the query.
Yeah. Okay. Cool.
And I still got limit 5. At this point, I can take the limit off and display all the records. Limit, I put in a limit just to keep things easy, visual for me, readable. And now I do the query again. I still got that 195 records with matching orders, with the customer name and stuff. All of this is in here. If at this point, if you wanted to sort something, you can also sort it. Let's say, Shobuz, tell me, what do I have to do to sort this particular table with customer name ascending?
Order by.
Good.
Order ID.
Customer name.
Oh, sorry, customer name. Then ascending.
Good.
SC.
Why do I have duplicates?
You have multiple customers have multiple orders.
They have multiple
orders.
Correct. They have multiple orders. So this is also valuable data. This particular customer, how many orders they have or they placed, and we may need to know that. We may also need to know address. Okay. So Tony, tell me, how do I add address here?
Address would be under customers or order? Probably customers, right?
Customers, yes.
Yeah. So it'd be customers dot address.
Yeah. You do that, run the query. Now you have these customers and you have their addresses. You see how I'm building on it?
Yeah.
This is how the database admins put things together to come up with what they want. They don't have the answer on their head right on the spot. They don't. So they're going to do these small baby steps and then look at the data and clean things up. And I want you to practice this way, because that's how you're going to register these commands, and that will be the best way. for you to remember things. Okay. All right. Now, would it matter if I were to flip this to? Let's say if I were to put an equal sign here, and then instead of this, I bring this here. If I change the order, what do you think?
It shouldn't matter.
It shouldn't matter, because you're just saying those two tables are what I'm going to. So this particular order, the customers, I don't have to put customers here, but that's the simplest thing to do. Okay. And if I do run the query, I get the same data. This order does not matter. But if I were you, I would follow a pattern. I would say first table, I put it here, so I'm going to put the first table here. Second table, I'm going to place the second table right there. Okay? If you follow that pattern, you won't make mistakes. All right. That's with that inner join that we have. And I may have a couple more examples. So let's take a look at, my animation is a little messed up. I didn't double check well. So let's take a look at this one. Display employee last name, order ID, and order date for existing orders. Now notice it didn't tell me which column that I need to connect this table with. It doesn't even tell me if it's a inner join, outer join, nothing. So what do you have to do? I need employee last name, order ID, and order date. So that's what you're going to go by first. So look for employee last name and order ID and order date. Employee last name, I got this right here. Okay, there's the last name. Order ID and order date. I got the order ID here in order details table, but I don't have order date. What about orders table? Notice the orders table gives me order ID and order date. So the tables that I need to join is employees and orders. Okay. Do I have a matching? Who can tell me what's a matching column for employees and orders? Here's employees, and there's
employee ID.
Correct.
Yeah,
Employee
display.
Correct. Employee ID, we have it in orders, and we also have employee ID column in employees, so we're going to join in that. Now, if I look at the question and it doesn't tell me that anything different about how I want to join it, automatically it's inner join. Okay. If it specifically tells me that take the table 2 and display everything from there, then we're looking at either left join or right join. You can get by with any one of those, and I'll show you how to do that shortly. But it doesn't say anything. So if it doesn't say anything, use inner join. Now, let's join them together first. Don't worry about which columns to display. Always start with displaying everything. So select, start, from. Tell me the name of the table.
Employees.
Okay, employees, and then what?
Then it's inner join.
Inner join. What's the second table?
Orders.
Orders. Good. And then if I use the word inner join, what's the other word I must use?
On.
On. And now I have to specify which column that was matching. What did we say? First thing, we take the table name. First, table 1. So it's going to be employees dot
Mhm.
matching column. What was the matching column?
Employee.
Employee ID. Got it? Put an equal sign.
You miss M.
Thank you. For the second part after the equal sign, we're going to take table number 2, which is orders. So you can do the close your eyes, take the orders, put a dot, and I told you that because we're matching the columns, would this column be different from this column? No.
No.
So you just take whatever you have in this particular column, copy that, and paste it here, and voila, you're done. At this point, I would recommend go ahead and put limit 5. Why? Because data is going to be much readable first. So let's go ahead and run the query.
You miss M. More employees.
Thank you. Employees.
On the bottom one too.
Oh,
on
there you go. Oh, because I copy pasted from the other one. Yeah. I got 5 records here because I limited 5, and notice it's giving me all the columns. If I scroll right, it combined employees and orders and gave me all the columns, but I don't need all the columns. So now I'm going to go in here and specify which columns I need, whatever my question asks me. Last name, order ID, and order date. So let's go do this. Okay. Haley, give me, what do I write for last name? Where is it going to come from?
Employees.
So you write the table name employees, and you can copy this whole thing if you want.
Mhm.
Same thing. Employees dot last name. Spelling matters. Case matters. Okay. Tony, give me the next one was order ID. Where's the order ID going to come from?
From order. So orders dot order ID, comma.
Okay. And Shobus, give me order date.
So I think it comes from orders also. So orders dot order date.
Correct. Now let's go ahead and run the query. Do I have those 3 columns? Last name, order ID, and order date. If you want to sort this, you can sort it if you want to. At this point, you can take off this limit 5 and display, and that will be your actual table of 196 matching records based on employee ID. Notice, did I even display employee ID? No. But the SQL is actually matching these 2 records, these 2 table records based on employee ID, even when I don't have to display them. And there you have it. Any question about that?
No.
All right, one last one, and then we'll take a break. I know I was going to take a break like 30 minutes before. Let's take a look at this. Display order ID, customer name, and shipper name from like customers and shippers. I got 2 tables here, shippers and customers, and I have to display certain columns. They didn't tell me what matching data we need to connect them on, right? So let's take a look at this. Here's shippers. We got the shipper ID. Is it shippers or suppliers? Shippers. Order ID, customer name, and shipper. So let's see. We got the shipper with the shipper ID. Orders. We got this. Notice the orders has the shipper ID.
Mhm.
Okay, so this particular one has that, but it doesn't have customer name.
Yep.
It's asking for customer name. Well, bummer, we're busted. Now we need to find another table that has that. But look, this has customer ID here. And if we go to customers, we got the customer name.
Mm-hmm.
Looks like, how many tables do we need to connect here?
3.
3 tables. We got customers, we have orders, and then we have to connect shippers. And we have to find connecting columns in both of these, all 3 of these, but 2 at a time. Meaning, I don't have to have a connecting column for customers, orders, and shippers. Is there a common column between customers and orders?
Yeah, customer ID.
Correct.
Mm-hmm.
Notice customer ID is the common column between customers and orders. Now, is there a common column between customers and shippers?
Yes.
Yes.
Shipper ID, right?
Customer and shipper?
Customers
No,
and shippers?
No, there is no mapping.
Oh, no.
So customers table and shippers table doesn't have any match. I got a shipper ID, but I don't have customer ID. So I can't connect the customers and shippers together. Sorry,
Mm-hmm.
bummer. But can I connect shippers with orders?
Yeah.
Under which column?
Shipper ID.
The shipper ID. Okay. So first you investigate and see if you have something matching between a combination of tables. Now we found that customers and orders have matching customer ID column.
Mm-hmm.
Orders and shippers have matching shipper ID column. So you start. First thing, select okay. Don't worry about which columns to display at this point. Start with the start. Otherwise, you will notice that you're halfway there and your query doesn't work and you can't fix it. Okay, it's gonna get complicated. So start with select star from, now give me table 1, any table you want.
Orders.
Orders, okay. So if you want to start with down there orders, which is gonna make things a bit tricky for me, but no worries. You can do it no matter which way you want to do. Because you said orders table, that's your table 1, and you have to say inner join. Now you have to say table 2, but be careful. Your table 2 has to have a matching record with table 1. Okay.
Mm-hmm. So it would be with.
So we got orders, and in here we had. Let me take another window here because I don't want to mess up the query. So here we got orders, and in orders we noticed that we have what? Customer ID.
Mm-hmm.
Okay. So do you want to?
You can match with either customers or shipper, right?
This, now that I'm looking at it, this could actually cause an issue. But let me do it in a way that it's not going to cause an issue.
Okay.
Okay. I don't know, but we'll try both ways. Notice that this particular table, orders, this guy has a friend in common. He's like the friend of customers table because he has his customer ID.
Mm-hmm.
Okay. And he's also the friend of shippers table because he has shipper ID. Exactly. All right. So I might want to put him in the middle.
Okay.
Okay. I might want to put him in the middle. So what I'm going to do is I'm going to start with customers first. Then I'm going to put this orders table in the middle because he's the friend of customers and shippers. And then I'm going to put shippers at the very end. All right. And I know that's going to work, but if the other order doesn't work, so I just want to do the right one first.
Cool.
Select star, and then I'm going to do from customers. Okay. Inner join. We're going to say orders because he's like the BFF. And then we're going to say on. Now we have to find a matching column. We know customer ID exists in both customers and orders. So here's my table 1. I copy that. Put it right here and put column name customer ID. That should match with my table 2. Column name, no space, customer ID. Any questions so far?
Yeah.
At this point, put a semicolon, run the query, and make sure you don't get an error. We didn't get an error, we got 195 records. Then you move on to the next one. Okay. Now, we just did inner join with orders. Okay?
Okay.
And I may still be wrong. I may still have to put this orders over here, but I don't know. I haven't experimented with this enough. So let's see. Now I'm going to inner join shipper. Shippers. And in the shippers, I got
Shipper.
You have to put join.
Loretta, what was that?
Inner joint, you have to write. Am I right? Or
Yes.
inner shipper?
Sorry, you're right. Inner join. Thank you. Inner join shippers. Okay. We got that down. We have to say another on. And you have to specify which one with which one. Right? So here I got orders, and I'm connecting orders dot
Shipper ID.
shipper ID. I just hope that Sql is going to be smart enough to understand that I'm just connecting those two, orders and shippers. Shippers dot, this would be shipper ID. Okay, as you can see, it's getting messy and room for a lot of error. Shippers dot, same thing, shipper ID that we're trying to match. Shipper ID. Okay. Questions so far?
Nope.
All right. Run the query. And voila. It worked. Okay, no issues. But we got a lot of data here. And we only needed to display certain ones, which in this case is employee last name, order ID. Sorry, not that one. Order ID, customer name, and shipper name. So going back in here, order ID is going to come out of which table?
Orders.
Dot order ID. There's a lot to write, guys, and this is what's going to get your feet wet when you get to Java, because when you're doing Java, it's you sitting in front of the computer, thinking analytically and writing analytic words. And every single speck of a character matters. If you put one comma less, it's not going to work. Good thing is you don't have to write an essay. It's very little writing, but that writing has to be perfect. There cannot have a single flaw in it. And there's an application to actually help you if you made a mistake to correct your errors, and I will teach you all that. So no worries. But get yourself starting to write these things. And I know at some point you're gonna pull your hair out, like, man, I can't believe I spelled that wrong, or I forgot that comma, and you're gonna get really angry because you're like, just for that comma, I spent 30 minutes debugging. And welcome to software world. And he saw that I spelled wrong here, and Shobuz corrected me, and some of y'all corrected me as well. So it happens. Just be patient. That's my advice. Anyway, orders.order ID, and then I got customer name and shipper. So let's do this really fast. I got this customers dot customer name and comma, and shippers. I got this shippers dot shipper name. Shipper. Huh?
Hi.
Was there a question?
No, I don't think so.
Okay, so we specified those 3 column names now. Order ID, customer name. I don't know if customer name appears as customer name here. Customer, yep, customer name. Now let's do the query here, and we got it.
Yep.
There's the customer name. There's the shipper name that we're going to be shipping the product through. At this point, if you wanted to order by customer name and run the query, it orders it for you, or whatever, however we want to sort things. Question.
Nope.
Would it matter
Understood.
if I did it with another order in mind? Let's see. So I'm going to go do this really fast now and not explain it. So I'm going to start with orders. And then inner join. I gotta find a matching one. Well, orders does have. Did I
Customer
start
ID.
with orders for the last one too, or just customers?
No, you start with customers. Yeah, because you want to put orders in the middle so you can pull both of the joins from top and bottom.
I see, I see. So let's do orders first, and let's try to make things complicated. So inner
Yeah,
join
fine.
customers, okay, or
Mhm.
or even make it worse, inner join shippers.
Yeah.
Okay. On,
Use it.
I know that shipper ID is going to match these two guys.
Yep.
So dot shipper, excuse me, shipper ID equals shippers table dot shipper ID. This dot concept is very much Java. So if
Yeah.
you are good with this already, I want you to practice and get this into your mind, how we go from the big table with a dot, a small something inside it. And then I could put another dot and go into the cell data. Okay, so just keep that in mind. That's how we're gonna get into Java. Shippers, orders, we got that down.
Yeah.
And then we're gonna do another inner join. This time we're gonna bring in customers, and we're gonna inner join on. But over here we have to be careful. We're gonna have to say customers dot customer ID
Yep.
equals which other table.
Orders.
We had the orders table that had the customer ID as well. I strongly believe it should work because SQL should be smart enough to understand that I am inner joining customers, but with this comparison, I am telling which table to inner join with. I want you to join it with customers and orders. So let's knock on wood, hit the search, and it still works.
Okay.
So you cannot go wrong in no matter what combination you put it, as long as your logic is sound, it's going to work.
Got it.
Let's take 5 minutes break and come back and do left join.
Okay.
Questions before we do that?
No, that was the only question. Like, could you make it out of order and it'll still be smart enough to read it? And we figured out it was.
Great. It was a first time discovery for me as well. I'll show you some real world application of, remind me before I forget this today's class, I want to show you what I'm doing in my work with SQL. So before I end the class, if I forget, call it out and I'll give you a demo.
Cool. Got it.
Are you guys back?
Yeah.
Okay. Hi. In any step of the way, or or any classes going forward, if you all need a bigger breaks than 5 minutes, even though do 15 minutes, 20 minutes, this is your class. So I want you to let me know ahead of time, and maybe we can work that out and do that. And sometimes you may need, sometimes you may not, and you may have to have some errands or something. So I want you to be flexible to ask me, and just want to let you know that it's totally okay with me. We're done with inner join. Let's take a look at a left join. For a left join, it will display all records in table 1. So we got two tables, table 1 and table 2. It's going to display everything. And it's not going to care whether there's a matching data or not. It's not going to care. It's going to give you everything. And then it's also going to give you the matching records for table 2. So pop quiz, is inner join going to give you more results, or left join going to give you more results? Which one?
Left join.
Correct. Because left join is going to give you everything plus matching ones from the second table. Inner join is only going to give you the matching between the two tables. Inner join is sometimes called left outer join, but that's not the code. You may see this somewhere. It means the same thing. When we're going to do SQL query, we're just going to write left join and not going to use the word outer. All right. Syntax looks like this, which is the same thing. There's no difference. Only thing different is instead of inner, we write the word outer. And the system that I just showed you in the to create inner join is essentially the same thing. So let's go and figure this out. Here's an example. Display all customer names. Notice this all. What does that give me a hint of?
Star.
Not necessarily. Notice all customer names. Didn't say all records from customers. Yes?
Yeah.
If it says all records from customers, then that's a star. But it wants all customer names. Where is customer name located?
Customers table.
Customer table. They want all customer names displayed. Then if my customers table is my table 1, I need to display everything that's in table 1 or everything that's in customers table.
Got it.
And then we got display order ID with matching names, with customer names in descending order. So we got to find something matching between those. With customer names in descending order, that's just order. Let's dissect this a little bit more. So let's go back in here. Here are our tables. We got this customers. I got 92 records. I got to display all customer names. So I should have 92 records when I display and more. We're also going to asking me to do order ID. So I have to display order ID that's in orders table. There's my order ID. What's the matching column between orders and customers? We saw that before. Customer ID. All right. And I got 196 records here. And I got 92 records in customers table. So when I'm going to do inner join, it's going to have a lot more than 196. You with me? It's gonna
More
have,
than
it's not gonna have less. It might even have just adding these two would be probably a good idea, but it's gonna be somewhere between 196 and whatever the total comes up with 196 and 92. But let's take a look at it.
The customer can do multiple orders, right?
A customer can do multiple orders, correct, and customer can have multiple order IDs. Since you brought that up, let's do a query. Shobus, why don't you do this? You give me a query to display order ID and customer ID from orders table with customer ID in ascending order.
Select order ID,
Good. Keep going.
comma, customer name,
Customer ID.
customer ID,
Come on.
from,
Uh-huh.
or the orders, right?
Good.
Yeah.
And then?
Order by,
Good.
is ascending.
Which
descending?
column? You got a name. Specify the column.
Oh, the order ID, customer.
Customer.
What is the ID?
Customer ID ascending.
Yeah.
Okay. So if I do that now, do you see this customer ordered twice? With
Right.
Right. Yeah. This customer has 4 separate orders.
Yeah.
Okay, so it's totally possible. Anyway, just going back to that, here's our question: customer name and order ID. We already isolated. We need customers and orders, and we notice that customer ID is the common column between them. So let's go ahead and formulate this now. So first, we're going to do select. Again, just put a star from, give me any name, any table, customers.
that's right. Yeah.
Before we did inner join, now because they want all customer names, we want left join. With me here?
Yeah.
We want left join, and if I say left join, but you gotta be careful with left join. If I say left join, then notice, technically I'm supposed to write it like this. I just do it this way so you can split things up. But when you go actually working for a company, you're not gonna write it like that. You're gonna actually put it right here. You're not gonna have a line break. You're gonna have it over here. So select star from customers, and when you say left join, whatever's on the left is that table 1. And meaning everything from the left table will be displayed. Understand?
Yep. Right.
And then whatever the table name you put on the right side, which is orders, is going to be table 2. Meaning only matching records from table, right side table will be displayed. Okay. I could have done this same query with just saying right join. All I have to do is flip the tables.
Right.
Does that make sense?
Yeah, that makes sense.
If I say right join, that means it's going to take everything from the right side table, which is customers, and only matching things from the left side table, which is orders. Essentially, I just did the same thing. This command will do the same thing if I flip it and write left join. Flip it again and say right join. Doesn't matter, it will give me the same answer. And probably that's why they didn't add the right join feature in this executor. so right join doesn't work. But that's okay. When they ask me to do something right join, I'm going to do it with the left join, just flip the table order. Okay, let's make it pretty. Now we have to say on what? Haley, tell me.
We join together.
There's the customer ID. I don't know if you can see it.
Oh, okay, customer ID.
No.
Wait, no, hold on.
The table name and then the column.
Dot.
Oh, okay. On customers
Good,
dot customer ID
good.
equals orders dot customer ID.
Good job. Okay, at this point, stop display data. Did I get more than 195?
Mm-hmm.
Good. That means we're doing something right. Now we need to add, we need to specify which columns. It's asking for customer name and order ID. Tell me how to write this.
Customer dot customer name or customer name, right? Or yeah. Comma, and then what's that called? Order ID.
Order ID.
So orders dot order ID.
Okay. Running the query. Notice I still should have 214 records. Now let's take a look at these records. What is that?
No.
Why is that?
Nothing. They were just, he didn't have an order ID.
Yeah, this guy, he doesn't have an order ID in orders table, meaning that was a not matching data, non-match. They couldn't find a match, but he didn't care. SQL, when you said left join, he took all the names from the customers table, regardless whether that customer ID existed in orders table or not. Understand?
Mm-hmm.
So let's also display customer ID in here to see how it looks like. He has a customer ID, but that customer ID does not exist in orders table. Therefore, there is no order out there. Okay. If I say order by order ID, I'll get all the data that doesn't have anything first because it's ascending, so there's null. Look at all these customers. They don't have an order. They are not the matching ones. If I did an inner join, this will get left out. Okay?
So it takes all the information from the customers. That's why it's showing now.
Correct.
Like we're not giving any order.
That's right. I like you guys when you verbalize it. I want to give you an opportunity because you have to explain these things in the interview. So it's nice if you can say it and explain it, boost your confidence. So all of these customers, even though they don't have a matching record, matching customer ID in the orders table, They do have a customer ID assigned to them, but these IDs don't exist in orders table. Therefore, it's still displaying them because you wanted to display everything from the customers table and also the matching ones from the orders table. And these are the matching ones. Now, if I take this and make this inner join and run the query, I got 195 records, and it took out all the null values. There's no more null. But if I change that to left, then it's going to give me all these customers that don't even have the records. Okay? That's all there is to it, by the way, guys. I mean, you can take this as far as you want to, but this is it. That's your left join. Any questions before we move on?
Nope.
Let's do a right join. And we're going to do a right join with a left join because it doesn't work, but we'll see if it works. Let me change this to a right join and see if it works. It didn't work for me yesterday. Notice it tells me could not prepare statement. Right and full outer joins are not currently supported. So this SQL executor does not support right now the right and the full outer join that I'm about to show you. So you just kind of have to learn this now. We are gonna back to this.
I remember last week we did the matching things that didn't match. Some those queries work on the MySQL, but not in this website.
Yeah, that's a bummer. But fear not, because when we go to Selenium and we're gonna pull data out of database to automate our test case, I'm gonna have a session, maybe a couple of hours, with you on hands-on MySQL that you downloaded in your computer. And if I have the time, I'll probably show you the outer join over there. So we'll cover the basis if needed. But again, a lot of these things are overkill because in the interview, they're not gonna go up to this join. If they give you a written test, they might ask you for these joins. Face-to-face interview, I was asked to give me a simple query with the select statement, right? It didn't even tell me, they didn't even tell me to do insert, update, delete. So anyway. All right, moving on to right join. Displays all records from the right side table and matching record from the left side table. So everything from table 2, only matching ones from table 1. Sometimes it's called right outer join, but don't get confused. It's the same thing. The command is written in right join only. Here's the syntax. No difference whatsoever. The only word is right join. Because the executor doesn't work, we're going to do it with the left join. Here's a question. Display existing order IDs for all employees, all employee last name. So all employee last name and first name with last name ascending order. Display existing order IDs. So order IDs for all employee last name.
Yeah.
Trying to synthesize that.
So you need employees orders.
Yeah, take a look at this answer right here. We got this right join. And they put employees on the right. That means they're taking all the employee last name and matching
with see the it's I think it's way too much on my side. Can you zoom a little bit less? I cannot see that.
What about the rest of y'all? I need this feedback because I'm not sure whether you can see this. Can you see this bottom part, employee.last name?
Yeah.
Yeah, I can see it. You just have that on the left. Oh yeah, it goes away. Like whenever you move your cursor, it has like little slide QA whatever thing. But
Don't move your cursor.
but besides that, I mean, yeah, like whenever you know, like right now it goes away. It's just whenever you move your cursor, like it's just whenever I don't know how to explain it. It's
Let me
your,
log out and log back again.
your pointer, captions, tip. Like whenever you're doing your pointer, the very bottom is like your little bar that you know how you can do whatever it is you want to do in your presentation. So that
that
little
gets in the way.
thing, it goes in the way just slightly over the very bottom left part where it says employee ID order. But now it's okay. Yeah.
I see. What
Yeah.
about anything changed now?
No, but if you start moving your order, yeah, see, it goes away automatic. Yeah, see, now it's gone. Yeah, that's good.
Oh, I see.
I don't see the bottom.
You don't see the bottom, Shobuz?
No, I think I may need to log out and log back again.
Yeah, I can see it fine.
Or it might be that what I'm thinking is maybe the window, the meeting room window, can you expand it and minimize some of those other panels like webcam panel and things? Shobu's already signed out. He's signing back in.
Okay.
All right, while he's doing that, let's take a look at these tables. Employee last name and first name and order ID. So here's employees. Employee ID, last name and first name.
So forth.
Here's orders, employee ID.
I can see.
Can you see now?
Yeah.
What about now?
I still don't see the bottom. I just see that. Yeah, I think I see it good better now. Yeah, I can see the query. It's good now.
Can you see all the way down here?
Employees dot last name, colon,
Yes.
semicolon.
Yes, awesome.
Yeah.
Okay, did you have to do anything different?
I just have to log out and log back in.
Okay, all right, great. So we got a common field here called employee ID. Let's go ahead and connect them. But the question is asking for all the last names. So if you look at existing orders, display existing order IDs for all employee last name and first name. So over here, I got the orders and these order IDs. So I want, they're wanting all of these employee IDs.
Yeah.
All right. These are the orders made, and companies wanting to know who these people are that sold this product. So did everybody sell it? Maybe, maybe not.
Yeah.
Right? It may have happened that some employees didn't sell anything, and they probably don't want them. They just want these guys, whoever number 5 is, number 6 is, and whoever is not listed here, they don't want it. All right? So they want everything from orders table. And they only want the matching names from employees table. Does that make sense?
Mm-hmm.
So with that, this is how I would do this. Select star from, doesn't matter who you want to say first. Actually, it does matter. If you want to say right join, you know that you want everything from orders. If I say right join, okay, then I have to put the table name that I want everything from to the right side. Make sense?
Yeah, that makes sense.
So because I want all the records from orders, I have to put it on the right side because I said right join. So I have to write orders. And I only want some. So I only want some from the left, just the matching ones from table 1 or the left side table. In that case, that employees, I think I messed it right there. Employees is gonna come right here. With me so far?
Yes, we're with you.
Okay. So I got everything from orders, only matching things from employees, and I'm gonna say on, and Shobus give me, what do I write here?
Employees dot employee ID.
Good job. Next part.
Equal to orders dot employee ID.
Yeah, this is like once you keep doing this, it's like you close your eyes and do that, right? Now, unfortunately, if I do a run SQL, it's gonna tell me that right join is not supported. Okay, so we are busted. Who can tell me how can I still use the same query with left join and don't have to do anything different?
You just get rid of right, put left when you switch your table. So it's going to go select star from orders,
Mm-hmm.
and left join employees, and the on statement can be the same.
Correct. So this part, instead of writing right, I can say left, and all I have to do is switch these tables orders. So take this one orders, switch it over here on the left side, and make that employees. I just flip the tables, and it still means the same thing. When I say left join, take everything from the orders, only the matching things from the other one. All right. Now, if I do the query, I got 196 records, and these are pretty big, thick records because of this column right here, notes column. Let's narrow down the columns. They're only asking for order ID and employee last name, first name. So we'll do order ID, orders dot order ID, employees dot last name, comma, employees dot first name, and these are the columns I want. If I do the search, I got those columns, and these guys made a sale. All right, that's the order ID they made a sale with. Order this by for visibility, order by last name, and we got this last names right here. Okay. It looks like this guy made a lot of sales.
Yeah.
Wow.
Laura, killing it.
Mm-hmm.
I have a question. So whenever you put order by and you put order by last name or order by whatever, you're not putting table name before the column name. So whenever you do order name, it automatically filters through all previous tables you're pulling from, whether it's just a from statement or you're doing a join, and it'll pull up a last name. Because you know how on select, you got to put what table you're looking at and then what column in that table with the dot. But you don't have to do the same for order by.
You're right. You're right. That's a very good discovery there. it may be designed in a way that by the time you have already put these statements out there, SQL already generated a table.
Okay.
And when this table is generated, he's already looking at customer name that belongs to employees. It's been generated, so he goes in and orders that. You don't have to specify. But again, if one day you try this query in your company and it doesn't work, if I were you, I would go ahead and put employees dot last name in here and try the query.
Yes.
If I do put the employees, does it break my query? No.
Okay.
It still gives me same result. But
Yeah.
in this particular case, do I have to? Nope. Still works.
Mm.
Good question. Anything else?
I know. That's the only question I had.
All right. By the way, these queries are on the slides, so you can look at it if you need to check it out later on. Full outer join won't be able to display this because it doesn't work. But the idea is if you say full outer join, it's going to take everything from first table, everything from second table, disregarding whether they match or not. And then if they have some matching ones, they might even duplicate and display them again. So it's not just going to be two tables, but also the matching data displayed as a duplicate. That means if I say categories and employees, if I do full outer join, I'm going to get not just 20 data, 10 from categories and 10 from employees, but if there are some matching ones, those will be displayed again. And I might get, let's say if there's two matching records here for those two, I would get 10 plus 10, 20, and then two matching ones, 22. Syntax, same, just changing full outer join. You can add a condition if you want to. Doesn't matter. Here's an example, but I'm not going to go there because it doesn't even work. And again, this is an overkill because they won't ask you questions about this in the interview. This is way too much for an automation engineer to know. Okay. Moving on. This is a new one called Union. Before we start this, let's take 5 minutes break and we'll come back and do Union. Are you all back?
Yes.
Okay. Before we get to Union, I think I just wanted to touch base on something that I have it assigned as a homework. I didn't want you guys to be confused about. Let's say I got two tables. One is called customers. Notice I have a city column right here and suppliers.
Mhm.
I also have a city column in suppliers. I don't have to match those two tables based on these IDs only. I don't. If I see that city column can be a good matching one, sometimes you want that. Sometimes you want to know if you have a customer who is living in the same city as the supplier. Why? Well, you might want to give them a shipping discount or some sort of delivery option where free delivery, something like that, because they live in the same place. So if I wanted to do that, it can be done. And in that case, you would need inner join between customers and suppliers with the matching column is going to be city. So I want to show you that it works. Select star from customers. Let's say I don't want star. I want customer name, customers.customer name, and suppliers dot supplier name, and from customers inner join suppliers on. This time we're connecting them with the city, so it's only going to give me matching cities. Customers dot city equals suppliers dot city, and do the query. Let's see, no column customers. I didn't notice that I didn't put customers, I wrote customer, so I table spelling inaccurate. Run the query. 9 of them, 9 customers live in the same city as the supplier. You may be asking which city. In that case, I can bring in customers, display customers.city, and these are the cities where the suppliers and customers live. Okay, you could order this city. Notice it's not understanding the column city. In that case, customers dot city. Now it gets it. Tony, did you see this?
Yeah, so I guess it does sometimes need to be clarified.
Yeah, it going back to your question, it was that do I need to specify the table name? And we saw that it worked before, but now it's not working. And that was my hunch that okay, then in that case, let me put in the table name. And now I got that ordered right here. Which city has most amount of customers living based on a supplier, and that will be Sao Paulo. Okay, and you can make decisions based on this data. Union. is somewhat similar. It combines results, but not for 2 or more tables, but it connects 2 or more SQL statements, SQL select statements. The catch is each statement must have the same number of columns. So the 2 statements you're going to connect, they both have to generate the same number of columns. Has to be in the same order. Columns have to be the same or similar, I should say. And they have to have the same data type. More about the data type a little bit later, but let's take a look at a syntax. We got a SQL statement right here, select column from table. That's one statement. And here's another statement, select column names from table 2, 2 statements. And we can union them together. If I put the word union, it's going to connect those 2 tables that you displayed with the statement. So whatever is displayed for this statement and this select statement, it's going to connect those 2. Only distinct data, meaning it's not going to duplicate anything. If there is a matching, if there is a duplication of those, it's gonna skip out. Not gonna show you that. But let's say you wanted to, even if there's a duplicate, just add them. Just give me everything that's there. Then there's another one called union all. If you do that, then it's gonna give you everything that's on this query, query 1, and query 2. Combine them together. I don't care if there's duplicates, just give me all. Then it's union all. And that will be all data. Let's take a look at an example here. So we got display distinct matching cities from customers and suppliers table ordered by city. Okay. So we got customers table, suppliers table, and display only the cities. So they just want me to display the cities. So the trick about these, you do it one thing at a time. So let's go ahead and display the city of customers table first. Select city from customers. Done. These are the cities. With me so far?
Yeah.
You copy this statement, put it in a notepad or something. Okay? And write down 92 records. Because you want to make sure that you did it right. Next, you display city from, what was the other one? Suppliers. So change that to suppliers table. Run the SQL query, you got 29 data out of that table. And these are the cities for the suppliers. There may or may not be a match. Take that query, go to a notepad, put it there, and write down 29. Okay?
Okay.
Now, what you do is you put them side by side. So you take this, you take the first query, put it here. You don't need the semicolon for the first one, so delete that. Write the word union and then go down. Take the next SQL query, including the semicolon, and run it. Here are the cities. Let's see what just happened. If I were to add 92 plus 29, I would get, somebody do the math.
127.
121?
I mean, 120. Yeah.
121?
121. Mm-hmm.
Okay. But it connected all the cities from customers and suppliers. Why do we only have 94 of them?
Because there could be duplicates.
There could be duplicates, correct. And those duplicates, notice you're not going to see the city mentioned twice.
Mm-hmm.
It will give you only the distinct cities and not necessarily matching ones. Understand?
Yeah.
It took all the cities from customers table. It took all the cities from suppliers table and it listed them by everybody, all the cities there. And if there was like a city which is, I know that there's a Berlin, that a customer is living in Berlin and a supplier is living in Berlin, it didn't mention Berlin twice. It just gave me all once. Therefore, I got 94 records, 94 cities. If you wanted to find out how many different cities of the world our customer and suppliers live in, that would be 94. But if I did union all, who can guess how many am I going to have?
121.
121. Notice the order got messed up, but that has nothing to do with anything. But if we order them, order by city, here you will notice that Berlin came in 3 times. That means there could be 2 customers living in Berlin and 1 supplier living in Berlin. It just took whatever that first column, first query had, which is 92, and second query had, which is 29, and added them together and gave you everything, even if there is duplicate. Any question?
Nope.
That's union, folks. Here's another example. Display all matching cities from customers and suppliers table ordered by city. Looks like it's the same thing. Oh, yeah. The union all. Okay. If it says all, then you use the union all. If it says distinct matching cities, you just use the word union. So let's do this here. Let's practice this. Get a list of customers, employees, and supplier names. Interesting. Customers, employees, and supplier names. Okay. How many tables are we talking about here?
3.
3 tables. Customers, employees table, and suppliers table. Man. And they want a list of names. So let's do it one at a time. Tony, give me the query to get customer names out of customer table.
Customer. So select customer name. from customers.
Good. See, this is easy. Like we've done this before. From customers. No big deal, right? You got 92 records, so take that baby step, copy it down here, there, and 92, just for the heck of it, write it down. Okay. Haley, give me employee names from employee table. Just give me last name is fine.
Okay. Select last name from employees.
Okay. Good job. 10. So copy that. Put it here. Somewhere in your notes. There's 10 records. Shobus, give me names of suppliers. Select supplier name from. Are you having sound issues? Shobus, can you hear me?
I was mute. Sorry,
Oh.
I was saying supply name from suppliers.
All right. Supplier.
I didn't know.
All right, good. There's 29 suppliers right here. So take that, put it in here. And there's 29. Now let's go ahead and create joins. So I take the first one, no semicolon needed. Pasting it and writing the word union. Did it say distinct? Get a list of customer, employee name, and supplier name. So obviously they probably don't want duplicates. And chances of somebody being duplicate here is rare, but an employee could be a customer too if buying something. You never know. So union, take the next statement. Obviously duplicate not needed. And then another union, and you take this one with the semicolon to finish off. Run the query. You got 131 records. Not necessarily that's what you're gonna get by adding all these, but actually in this case, that's it. That's all of them because there is no duplicate. Oh look, I probably added this one. It didn't delete yet in the database. Anyway, if I do all here, I can also write all, but my guess is I'm gonna get the same because customer name, supplier name, and employee name, they're very they're unique. They're separate people. I don't think there's an employee who is a customer, but that could be different for a different company. Any question about union?
No.
All right. That's that query. Get a list of customer names and supplier names located in Germany. How are we going to do that? Located in Germany. So we're going to need a what kind of clause, SQL?
Where statement.
Where statement.
Where?
So first you create a where statement. Now you're going to need how many where statements?
Get a list in Germany.
Actually, you're going to have two separate. Remember, union is going to require you to have two separate statements, and you cannot combine them with the where statement. So
Yeah,
first, correct. So first statement, you have to find customer names where they're located in Germany. Second SQL statement, you have to find the supplier name who are located in Germany. and then union them together. So here's what I would do. I'm not using Notepad anymore because you got the idea. Select customer name from customers where city. Can I do this?
Is
I noticed that Shobhu's used the word is actually works just like an equal sign. On his homework, he used that, and I totally forgot to bring that in. So you can use equal sign, or you could also say is. Value goes in the quotation, Germany.
Is it country?
Sorry, yes, you're right. Country, Germany, semicolon, do a search, see if you got results. 12. These guys are in Germany. Good job. Take that semicolon off, say union, write a totally new SQL statement. So select. This time, we're also looking for some sort of name. Now, notice that we mentioned that there has to be same number of columns. So this SQL statement, Tony, how many columns is it giving me?
Is going to be in it? Just one.
Just one.
Oh, sorry.
Yeah.
2.
Just one.
Oh, okay. Yeah.
See that?
Yeah. Because you're not
Because
displaying country. Yeah.
Because I said select customer name, I only selected one column. So it's giving me all this customer name. Now, if I have a select statement, but I put this one is going to be supplier name. What else is there in supplier thing? Let's see. Here's suppliers. There's supplier ID. So if I add supplier ID, he's not going to like it.
Mhm.
Union is not going to like it. In this select statement, I'm displaying 2, or I'm getting data out of 2 columns. That's not going to be good. From suppliers, here, country. Notice same thing. I can put equal sign in quotation, say Germany. And now close quote, semicolon. If I run the query, it's going to give me an error. Union do not have the same number of result columns. Does not have the same number of result column. This result gives me 1 column, and this result gives me 2 columns. He's not happy. Well, what if I just do 1 column? What if I take the supplier name off? What's wrong with this one? Who can tell me?
Supplier ID and customer name. Supplier ID is a number. Customer name is not a number.
Absolutely.
They're two different kinds of characters.
Absolutely, that's correct. This could be a number, and this is a text data type. And if their data type doesn't match, it could give you an error. I don't know if supplier ID is saved as what data type in this database, but let's do a SQL query. It didn't give you an error because it's right now is set at same data type. But supplier ID should not be saved as a character data type, which I'm going to show you in shortly about data types. It should be a number. So this is not a good setup. It will work now, but it shouldn't. Anyway, so the correct column should be supplier name. All right. Now, if you do the query, you got 15 records. You got all the customer name, that these guys are in Germany, and you got all the supplier name in here that are also from Germany. All these guys, customer either or supplier, are living in Germany. Any questions?
No.
You've seen we created a temporary column name. Remember we changed this column name. If I wanted to, I could change it. Who can tell me how would I change this column name to, let's say, just say people?
So after select, the select supplier name as people.
Okay. That didn't work. Why? Anybody wants to try?
You do the same for the top one as well. No. Oh yeah.
So it worked?
Yeah.
Do I need the bottom one?
Do you? Do they have to match, or does it matter once you state it in the beginning?
As long as you have the top one,
Okay.
the bottom one does not have to match.
Got it.
But you can't just write it in the bottom. You have to write it in the top, because this is how SQL is going to generate that table name, column name for you. So it wants you to specify it at the very beginning, and SQL goes from word. Okay, and then it comes down here, and they will get confused here. All right. Who can tell me if I wanted to say, if I wanted to put 3 words in here, people in Germany, how would I do that? This column name would be people in Germany.
You gotta do square bracket.
Square bracket, correct. So put 2 square bracket here and write people in living in Germany. Okay.
People typing mistake.
Yeah, sorry. People living in Germany. Run the query, and you got people living in Germany. Column names have changed. Okay. Now, what if I wanted to put another column here? Okay. Bear with me on this. I'm going to take this knowledge to a next level. What if I wanted to put another column? Why? I got the names of these people living in Germany, but these are actually customers and suppliers, right? Customers and suppliers. That "and" might have a problem. Let's see. Suppliers. Yeah, the customers and suppliers living in Germany. By looking at this list, does anybody know who is a customer and who is a supplier?
No.
Oh,
Not really. So if I give this list to an executive and tell him these are the people, he's going to ask, well, who is the customer and who's the supplier? This table doesn't give you the data. Well, we got to generate that. Okay. So if I wanted to add another column here, okay, imagine adding another column, something like this. Suppose we're going to add this column to the left side, but I'm going to draw it here. So let's say we got another column, and we're going to say customer type or type of people. Okay. And in here, because this is a customer, we're going to write customer. Okay. And if this is the supplier, it's going to say supplier here. With me so far?
Yes.
So for me to do this, where it's going to say either a customer, this one is a supplier, it's a customer, supplier, all right? For me to do this, I have to use this idea, same thing, which is the alias thing that we have done, but except, notice what we've been doing is we write the column name, and then we write as, and then we put the name that we wanted to display as, correct?
Yeah.
This time, it's kind of the same. We're still going to use as, and we're going to use the name that we wanted to display as, which is, we said type. Like we wanted this to be called, let's say type. We'll display it on the right side, okay? Type. Or people type, basically, okay? So that will be after the as. Same as we did this up here when we said as, and then whatever the name we wanted. With me so far?
Yeah.
Okay. But we also said that we're going to have some sort of value here. So we know we're going to say as, and then the column name called type. But we're going to have supplier here, customer, supplier. We're going to have values. These values are going to go here. Understand?
Mm-hmm.
And what do we put around the values?
Quotation marks.
Quotation mark. So we're going to have to add the value on this side, left side. So value as, and then a name for that column, it's going to show up like this. Let's take a look at what I'm talking about. Okay.
It's going to be long and tedious.
Yeah, it could be messy, but let's go small.
Okay.
So we said we had this customer name, and we don't need to change the customer name. Select customer name from customers. Where city is Germany. Where country is Germany. Yes?
Yeah.
But we said we wanted to have another column. Yes?
Mm-hmm.
Where does the columns go? Right after the select. We already have customer name column.
Yeah.
So if I wanted to add another column right next to customer name, I put a comma. Yes? Nothing new, the same thing. But the formula that I gave you is you put the value that's going to go in there and then write as and then give the column name. So value, because these guys are all customers, I would write customer as the value. Meaning that's what's going to go inside the table data. Okay?
Okay.
And then I'm going to write as, and I'm going to give the column name whatever name I want. And I could say type in short. Okay? Or person type. Person type. Okay? If I do this query now, guess what happens? I got this person type, which is the same thing as I wrote here. Okay? And these value that I assign, that went right there. Understand?
Got it.
All of these got this value. Everybody, doesn't matter. In this table, everybody got that value down here. Everybody. Now, if I union this one, select supplier name, okay? This time, I want to say my second column is going to have the value what? Supplier. And then I'm going to say as. I don't want a separate column. I need the same. Remember, it has to have the same number of columns. You could say same thing, person type, from suppliers, where country is Germany. Okay? Close it. There you have it.
Okay, gotcha.
Right there, there's a supplier. This guy is a supplier, but these guys are customers. That's a supplier. If you want to order this, I don't know if that's going to let you, but let's try. Order. We may have to do it separately. Order by person type. Oh, what do you know? It worked. If I say descending, we got 3 suppliers.
Descending order.
And these are all customers.
Cool.
And these guys, these are special because these guys all live in this country, Germany. Okay, it's sorted out by Germany. I think that's it for union. Any question?
Nope.
Okay, and you learned how to assign a temporary name.
Yeah.
Syntax. You say value, whatever you want that those data to be in that column, and then write the word as, and whatever you want that table name to be, a column name to be, and then you got that. So this is the same thing that I just explained. Next, this is totally overkill, folks. You're never gonna use these commands working as a automation engineer. This is only for database admins. But I'm not going to give you any examples. I want to just kind of touch base and move out of here. So you may be asking, well, how do you create a database? Simple. You just use the command create database, and then you give it the name of the database, whatever database you want to name it. Put a semicolon and hit enter, and it's going to do it for you. This is not going to work in this because they designed it in a way that you cannot create another database. This is a database of tables, and that's it. So in your other one software that you downloaded, it will work. An example, if they ask you a question, create a database called test database or test DB. All you write is create database and then give it the name test database. Something like this. Simple? Database, whatever the name of the database, put a semicolon, hit enter, you got a database created in your system. What about, it looks like it's a repeat. This should be delete. How do you delete a database if you wanted to delete it? Ignore this, this is a typo. This is fine though, you must have admin rights. If you don't have administrative rights in the database, you won't be able to use these commands. It's not going to work for you. You'll be able to do the SQL select commands but you won't be able to delete it. Delete in SQL is called drop. It's not delete. Okay, for deleting the database is called drop. So if you put the command drop database and then give the name of the database you wanted to drop or delete, that will get deleted. Okay, so if the question comes, delete the database called testdb, you would say drop database testdb. What about if you wanted to list all the databases that are there? You would say show databases. It will list you all the databases that are there. And last, if you wanted to store all the data in the database into a secure place, in case your database crashes, you can still access it, you would say backup database and then write the database name. Then you would say to disk with an equal sign, and then put the file path of which file you want to store all that data to. Actuality, it looks like this. Backup database, let's say test database we want to back up. To disk equal, and then that's the file location on your computer where you want to store it. And it's going to store all that records in there. Any questions about these? Create database, show database commands.
Nope.
Good. This presentation doesn't work very well. I didn't get a chance to, I just made this up this morning. So I haven't had a chance to put animation in it. So ignore these showing up right now in out of order. But let's take a look at what data type is. You have probably heard me saying the word string several times. And then I kind of shied away from explaining what that is. String has a huge connotation in Java. I can't explain what this is yet in detail. But whenever we say string, I want you to understand that it is just a sequence of characters, meaning letters. Okay, like this whole sentence is a string. It's a sequence of characters. This word is a string. Okay, even this letter can be a string. Okay, so anytime you have characters like this or letters, even numbers, all of these can be coded as a string. And this is heavily used in programming languages, and I'll explain you later why. Right now, let's take a look at some primitive data type. Essentially, in software world, data can be broken down into simple few types. All right. Number one is numeric data. It's numbers. Anything to do with numbers is a numeric data. Why is that? Why do we need to worry about this numeric? Is because if we wanted to, let's say, do some mathematics to it, then it matters how we set up the data. Okay, it has to be numeric for the data to do any kind of adding, subtracting, and so forth. Inside the numeric, you got some other broken down into, one is called, this should be integer, okay? I think there's a typo. Integer that doesn't have any decimal. And then there is a data that has a decimal point, okay? So a solid whole number, let's say 245 or 350, you get the point? That will be an integer. Minus 10. integer. But float is the decimal name for, if I have, let's say, 2.4, that will be a float.
Got it.
0.25, because I have a point, that will be a float. Okay. So there is more to it. They call it float. There's a double or decimal. Different software languages, softwares like Python, Java, they may have different ones, but essentially it's the same thing. For now, I just want you to focus on two things. One is called integer, that's a solid number, and a float, that is a decimal number. Instead of saying decimal, we're now going to say float or floating number. Okay? If I don't want to do any mathematics to it, then I have a data. That data, if it's just letters, words, sentences, all of those fall under something called string. Okay? And in string, for softwares, programming languages, we call string. For Sql, we're going to call it varchar. Varchar comes from the word variable characters. Okay? Or various characters, meaning these are all character. Here's a character, and various or variable characters, which is the same thing as string. Java is going to use the word string. Python uses the word varchar or var, just var. SQL also uses varchar and also uses char or car. How we just say varchar. It's short for characters. But anytime we have these data type, it means nothing but a string or a sentence or list of characters. Another data type is called date time, and they have something called timestamp, date, interval. I'll show you timestamp in my company, and you'll see how that looks like. One last thing to finish off is called Boolean, and this Boolean is either yes or no. Don't worry about binary for now. Just with these, we're going to proceed with Java, and then we'll go deeper into it. Okay. Any questions about data type? Don't worry about binary for now. Just with these, we're going to proceed. Okay. Any questions? That's weird.
No.
Did I just hear my echo?
Yeah.
I don't know how that happened.
Yeah.
Anyway.
Yeah, no.
All right. In SQL, we're going to look at varchar or char. For numeric, we're going to use the word int for short, integer. We can use float, but I'm not going to give you all that examples. And let me move my cursor away, pointer. So you can see the bottom part, which is date. You may have a homework with the date thing. It's no difference, but I'll show you how to use this now. Reason we need this is if you wanted to create a table yourself, you're going to have to specify data type. So let's go ahead and create a table. How do we create a table? Here's the syntax. Syntax is you have to write the word create table. W3 School does allow you to create a table within that database. It doesn't allow you to delete the table, by the way. So that's a bummer. Create table, you give the name of the table, open parenthesis, close parenthesis, inside, name each column with the data type you want. Okay? With a comma, second column, data type, third column, data type, and so forth. Let's take a look at an example. Here is a question says, create a table called persons that contains 5 columns, including actually 4 columns. Person ID, last name, address, and city. We're just going to say person ID, name, address, and city, and create 4 columns in this table. Does it give me any data type? No, it doesn't. So let's do this. Here's my SQL query. You say create table and give it the name of the table, persons. Okay. Open bracket, close bracket, semicolon to close. You don't have to hit enter to go down there, but it looks nice if you write, if I go down here and then write this. Here's column 1, which is, what did he say? Person ID. So I can say column name, person ID, and because it's column name, you don't have to put, it's not value, you don't have to put quotations around it. You just say person ID. And now with the space, you have to mention what kind of data type is it. The very common data type in SQL is varchar, V-A-R-C-H-R, and with parentheses, you have to mention how many characters. Reason is, going back to this, I don't know if you can see this fine print. The difference between character and or char or varchar is the size. Char is going to allow you 0 letters to 255 letters. Okay. Varchar is going to allow you to have 0 letters to 65, over 65,000 letters in that column. So sometimes you can get away with char, sometimes varchar. Okay, you may need varchar. Like if there's a lot of data, you would need varchar. Let's do this. We'll have a combination. Person ID, we're actually going to use this as an int. Okay, we're going to use int for person ID, and int is going to allow you, notice it's huge, negative 21 million or something, to 0 to a positive of that number. So you can put that big of a number. Anything bigger than that, then you need another data type for that. So you have to specify how much. We'll just say 1,000 maybe. Okay, and then get down here. Next column, we want name. Just 1 second. We're gonna call it a name. Oh, excuse me.
Last name.
Yeah, we'll just say name.
Okay.
Name, and now name could have a lot of characters. Let's say we say char is fine. And in here, over here, I have to put a comma. Let's say maximum is going to allow us 255. I say 200. Okay. Then we have address and city. Address may take a lot more, so we'll go varchar and put 300, comma. Last column, city. We can say char. Open, close. I don't think any more than 200 is needed. And there you have it. We're done. If I hit enter now, I can even bring this here maybe to make it look pretty. Notice what it says. You have made changes to the database. And look at these tables right here. What do you notice?
We added a persons table.
We added a persons table. It doesn't have any data in it. If I try to display anything, it's not going to display anything, but I can start adding data in here. Okay. So, Haley, give me the SQL query to add data in this table. Notice the person ID is integer. This is a number. Name, address, and city, these are all character sequence or string. So what do I do? How do I add? Do you remember?
Insert
Good.
into.
Mm-hmm.
The first one is a number, right? Oh no, it's person. Okay.
Persons.
So it's the name. No, hold on. Parentheses. I really don't remember how to do this, to be
You
honest.
got it. You're almost there. You got the insert into persons. You got the table name. Now, you don't have to mention the column names where you want to insert the data. If you insert data into all columns, which we're going to do, all you have to say is what values. So you say values. And then here you specify those values. So you know the first column is person ID. Is that a number or a character?
Number.
So you put a 1, you don't have to put quotations. Second column is name. So let's say Johnny. Okay. Third column is address. Because it's varchar or character, you have to put quotation 1, 2, 3, 4 street. And then the last one is city. You say Dallas. All right. Now you hit SQL query. Row affected 1. Notice persons table got 1 data, 1 record. And if I wanted to display this record now, select star from persons. There you have it.
Say I do insert into persons, and then I do values like we just did. 1 Johnny, 1, 2, 3 street Dallas. Can I do then after that values another value statement with another open and close parentheses and to put another another value into this table, or do I have to do another insert into?
Tony, that's a very creative question. I've never tried, but let's try it out. Insert into persons, values. My bet is it's gonna work.
Okay. Yeah, because then you can just do one insert into statement and then just however many values you want to do, hundreds, 5, 6, millions, doesn't matter.
Let's see. We're gonna follow the standard.
Okay.
So how are we gonna put this here now? That matters. So if you have any other recommendation, you can ask me. I can try it here. I think I may have to put a comma here, but I don't know.
Okay. We can find out.
May or may not work.
All right. But Adrian or Mike can do that.
Semicolon. Value syntax error. So it's asking me to fix this because there's 2 of them. What if I put a comma here?
No. Okay.
Still an error. What if I created a set?
Okay, yeah. Another set of data.
So I got a set right here, and then another set right here. Don't know if that's gonna work. No such column 2 and 3. It's not working.
Okay. Yeah, I just a thought.
So, Shobuz, do you have any suggestions? I know you had some experience with this.
No, I don't.
All right.
I cannot think about.
All right. Are you all good with creating tables, or do you want me to give you more examples?
No, we're pretty good with it.
All right. Let's move on. That was the other one. Alter table is something that you want to change some things, meaning add, delete, or modify columns in existing table. SQL W3 School doesn't support that, so I'm just going to show you what you can do for alter tables. And again, this is an overkill for you as an automation engineer. You will never do that. Alter table and write the table name. If you wanted to add another column name, actually this is going to allow me. Let's try this. 1 second. So let's go ahead and add this person's table. We're going to add one more column. So let's see if we can do this.
Can you Control Z? Can you do the Control Z, please? Yeah. Just can you take out the just put comma, open bracket, and take out the square bracket. Yeah, take out the square bracket.
Both of these?
Yeah, both of this. And separate by the first bracket with both of the data. Yeah.
Oh, okay. Yeah. So 2 independent.
Yeah.
Yeah, just like that.
And take out,
Is that good?
yeah. Can I try that?
Hey, it worked.
Oh, wow. Cool.
It worked.
All right. So that way it saves us from inserting 2 times.
Yeah. So just put a comma, but don't add the word values.
Yeah.
Yeah.
That's the mistake we made. Yeah. So here's
Cool.
3 sets of data added now. Very nice. Thank you. Good. Okay. So alter table, and we're going to add a column. This might allow me to add a column. Let's do this. We got alter table. This time you have to say the word table. And you have to say which table, persons. And add, you want to add a column. Let's say we'll add a column called email. Have to say what type of data type it is going to be. Varchar. And let's say 300 maximum characters. Close it. Let's see if we got our syntax right. Column name and data type. Yes. Column name, data type. Let's go ahead and add this. You have made changes to the database. That's a good thing. There's the persons table. Open it up. Notice now you have email column, but displaying null data because we never put anything in it. Okay?
Yeah.
So you can also alter, meaning you can modify the data type, let's say, if you wanted to. If I didn't want email to be varchar, if I wanted the email to be char, I could say alter column, email, and then specify again, and that will change that. But this doesn't work with SQL here. Let's try this. Alter table persons and alter column, which is email. And if I now wanted to make this, instead of varchar, a just char in real world, I should be able to do this. I put 300 before, I can put 200 on this one. 255 is the max. I'll be surprised if it works. It doesn't work. Notice alter syntax error. It's not gonna allow you to. I do have to put alter column, but still it doesn't support. Alter syntax error because it doesn't support, but it's supposed to work. Same thing. Certain places you have to say, certain softwares require you to write alter column or just alter. Some require you to say modify column or just modify. You have to adapt to this when you go working for a company and whatever the software that they're using. Again, for automation engineer, you will never use it. I have some examples here and you can use this. Delete also works the same way. It's called drop column. If you wanted to delete the column, say drop column, this doesn't work on this W3 School. But you can read about it. We're almost done. I just have a challenge question and I'm going to walk you through this. This is going to be probably the most complicated SQL query. And then we're done. So get a list of customer names and addresses, products, and quantity of products. Should have said ordered by something, I think. Anyway, here's the strategy. First, what you need to look for is identify required tables. Once you did that, identify matching columns. Then you display all columns and then try to do join with a limit 5. When you're done with that, your query comes out fine. You remove the star symbol and then now you specify which columns you want. And then you take off the limit 5. And let me show you how to do this. So get a list of customer names, addresses, products, and quantity. What they're asking us to do is the executives are asking you which customers' addresses, give me the customer name and addresses who ordered a product. I want to know what product that they ordered and how many did they order, quantity. They want to make a decision based on who ordered what product and how many. Maybe give them some sort of reward or some sort of marketing. Or you as a software engineer, you need this data so that you can shoot certain marketing towards them. Facebook does it. Your YouTube does it. Have you noticed that? I don't know if you ever noticed, Google and YouTube is owned by same Google company. So if you go to Google and let's say you search for top 5 routers and you read about it, what happens is Google software takes your search data and connects your search data with YouTube videos in the background. You don't even know that they're doing it. And then when you open up the YouTube, Guess what's displayed on the homepage of the YouTube? I don't know. Some people that made videos on top 10 routers is gonna display on the stuff. Okay? So how are they doing that? They actually use data. Every time you search, it goes into their database. The records go into their database. What did you type in? Record goes into the database. And then they have the software to pull this data and mix it up. They have their marketing data, videos in YouTube. They mix it up, have some intelligent logic in programming language. And when you open up YouTube, automatically it knows, I can make a better marketing choice with this guy and get him hooked into YouTube for a little bit longer. He will look at this video, watch it, and he's going to click on it. Whoever has the advertisement on that video will get hit, and they're going to send me money as a YouTube company, and we're going to get rich. Okay, so all of these things, intelligence is built into these companies now. Okay, and just keep a know-how of it. Anyway, that's what we're going to do. We're going to get customer names, addresses, and find out what product they buy and how many are they buying to make some intelligent choice. Let's do this. First thing, which tables? Who can tell me?
Customers.
We need customers. We need name, address. What else?
Quantity. So you're going to go to product.
Products only has product name,
Okay.
which
so,
we're going to need. We're going to need this too. We're going to need product name. What else? Where are you?
Orders.
We're going to quantity orders or order details.
So if I go to order details, notice I have the quantity.
Yeah.
So we got a monumental task here. We got to connect the customers and find what product did they order in what quantity. But our first task was to narrow down how many tables, and how many tables did we find?
3.
3 tables. We got customers, order details, and products. So start with that. Select, remember, again, I spelled it out, your step-by-step brainstorming. You identified number of tables. You have to find the matching columns. We already know that from our previous example, that there are some matching columns. We also noticed that order doesn't matter, right? As long as our logic is sound. Which table we put first and which table last doesn't matter. We display all the columns initially with the star. So right now, that's what we're doing. We are saying select star, first table. Who cares? Let's call it customers. We know we need that. Okay?
Yeah.
Do we need inner join, left join, outer join, or full join?
Inner join.
Correct, because we want only the customers that match with the other tables.
Yeah.
We don't want everybody. We just want whoever had the sales, whoever bought the product. So we're going to need inner join. Okay? And I don't care which table you want to say it. We know that order details table, we're going to need that, correct?
Yeah.
So let's go ahead and get that. Order details. Okay? Now we have to say on here, we have to be careful because we have to connect customers and order details on a specific column. Here's customers. We got customer ID. And here's order details. We also have, we don't. We don't have customer ID. So that's not going to work.
Product ID.
You see that?
Yeah.
That's not going to work. We're going to have to take the help of somebody else. What about orders? Do we have customer ID in orders?
Yeah,
Yeah.
customer ID.
Okay, why don't we connect that first, okay?
Yeah.
So let's go to orders. And join on customers.customer ID. Guys, this is the toughest thing you ever get. Most likely nobody's going to ask you this tough question. Customers and orders.customer ID. Okay? Let's go ahead and search this and see if things work or we made a mistake.
You need to put as on customers.customer ID.
Correct. Baby step, you connected one, you got all the columns from customer ID, matching ones with orders. Okay, so these are the only customers that placed an order. Are we good so far?
Yeah.
It's a good data. It's a good data to have. Okay, now let's go and connect somebody else. So let's do inner join. All right, now we know this orders table, we need to connect with this order details. Didn't we say that? Because it has the quantity. Yes?
Yeah.
Yes.
But we also have order ID here that I can connect with orders table.
Yeah.
So I can just say inner join order details on
Orders.
dot
Order ID.
order ID equals
Order detail.
order details dot order ID. Good so far?
Yeah.
Notice I said put a limit of 5 records because it's easy to read. So I'm going to just do that for now. Limit 5. Scroll down, look at this. So far, you have to bring all this data you need. I need quantity. I got the quantity. I got the customer name and address. You have to join them so that you get them first. So let's see. Customer name, address, I got quantity, I'm missing products. Look at this, I don't have products. I gotta bring in the product here. Let's take a look at the products table. What do I have common here? Product. Notice product ID is also located where? Order details. With me so far?
Yes.
Order details has product ID. Products have product ID. And this is the column I need to display, but I'm going to bring in all of these guys connecting with product ID. So let's continue doing that. I'm going to back down here, go again, and say inner join products. Okay? On. Come on, guys. Products. Yell out.
So you have a mid ID.
Product
Because the-
ID
Equals.
equal ordered. Was it order details?
Yeah. Order details.
Correct. Order details also has this guy. So
Okay.
order.
Product ID.
Product ID. Done. Hit the query. Every time you do one step, you hit it and check. I hit it. I got 5 records. Scroll down. I would probably like even less, maybe 2 records, because I got the scroll bar down here. Keep scanning. Make sure you got those columns first. Do I have customer name? Yup. Do I have address? Yup. Do I have product name? Yup.
Quantity.
Do I have quantity?
Yes.
Yup. Now, this thing, I'm only going to have to narrow it down to how many columns I want to show it to my audience. Okay? This whole mess is giving me all of these guys, but I don't need to display all of these guys. I just want to display certain columns in certain order, and that's what I'm going to specify by deleting the star. So when you go here, last thing says remove the star to specify the columns you want to display. Right? So I go in here, I take off the star, I read the question. The question says customer name first, address, products, and quantity. So I'm going to go in here, delete the star. Tony, give me customer name.
So customers or customer name, yeah, customers dot customer name.
Notice he mentioned the table name first. Customer name, comma. Next thing they wanted is address. So Haley, give me address.
Customers dot address.
Okay, comma. Next thing wanted products. So Shobuz, give me products.
It means products dot product.
Products dot, I think it's product name. Let's see. Product.
Yeah.
So that's going to tell me what product they bought. So product name. And Loretta, give me the last one, which is quantity. This is part of the order details table.
Order details.
Order details,
The period.
period or dot,
Yeah. Quantity.
quantity. Yeah, always say dot.
Or dot.
I know it's period, but in Java they use the just say dot.
Okay.
Because period means more like an English word. This is more like a programming language. So we got this 4 tables in certain order and hit the query. First look at it. Does it make sense? I got this guy, this address. He bought this product, queso cabrales. I don't know what that is. Maybe cheese. Queso is cheese. And 20 packages of them. Same guy, same address, bought some other fried food, 10 quantity. If this makes sense, we got 4 columns on a display. Now your last step, you go into your query and you take this limit off. Delete the limit. And then hit the search. You got 514 records with all these people, with all the products that they ordered, and the quantity. And if you want to sort this at this point, you can say order by something. And we have it done. Any question?
No. It's long, tedious.
It's pretty long and tedious, but is it doable?
Yeah, definitely doable.
Absolutely. And look, guys, you want to make the $100,000 and call yourself the engineer? Well, this is where you have to be. Okay? You have to, if you want to make a lot more money than somebody flipping burgers in a fast food place, like 5 times, 6 times more than them, then obviously you have to think different. You have to be different. And I want you to start taking that into yourself, that you can't be who you are today and start making $100,000 tomorrow. You won't. You have to change and become someone higher level. And you have to believe that. And once you believe in yourself and you practice and you be that, people will see that in you. And people will see value in you. And they would want to pay you that $100,000 to do things for them instead of some ordinary people flipping burgers. Okay? So, anytime you see something complicated, I want you to jump on it and learn it, because that's where the money is. That's where that's going to make you different from somebody who makes $15,000 a year in fast food industry versus you making $100,000. Okay? You are not going to be the same person anymore. Besides, I hope that after you're done with my courses in Selenium and automation and stuff, your intelligence is going to shoot through the roof, and you are going to feel different about yourself. And I want you to go there. So practice makes a man perfect. If you practice this, you're going to be successful. Before I finish up the course on SQL, this is the last piece that I have for you. There's nothing to practice, really. I just want to sum up things for you now, and then we're done. So, what did we do so far? We actually did a whole bunch of SQL commands, and these commands fall under certain category. Interviewer is going to ask you on this, so you need to study this slide. What we did first, we started with SQL select queries. This is where you're going to live in your automation engineering. You're not going to do the other ones. So this is called data query language, or in short, DQL. You need to know what DQL stands for, because the interviewers are going to ask you, what does DQL stand for? And they have a script, and this is very common. You will get questions on it. So memorize the heck out of this PowerPoint slide. Data query language is when you look for data out of something and you don't change anything. You just display it temporarily and then it dies out, right? That's what select query does for us. The very next thing that I taught you is this insert, update, delete. If you remember one of my PowerPoint slides, you may not even have to do this, but probability is high compared to anything else. Highest is select. This is called DML, or data manipulation language. Manipulation means you want to change things, mold it, maybe delete it, but it's only data level. You can only change, delete certain data. Again, your database administrator will probably not give you access to do that. So, but in the interview, they're going to ask you for it. What does DML stand for? It's data manipulation language. Memorize it. The next thing that I just showed you today, some of them, which is create, we were able to do that. We were not able to do drop or alter. Drop is for delete and alter is for changing things in the creation level. Okay, this is creation level. This is the structure. Okay, create is when you're creating the structure of the table. Insert is you're just inserting data into the table. These are even more restricted to database administrators, and these are called data definition language. Data definition, meaning you are defining the data. You're defining the table. How is the table going to look like? What is the structure going to be? What is the data type going to be for a certain column? This is a very architectural level commands. You will never use this as an automation engineer. But just know what DDL stands for. What is DML? Interview question might be, can you tell me the commands that, can you tell me the DML commands? What are you going to say? Well, you're going to say insert, update, delete. Okay. So memorize it. If you want to you don't want to memorize it, but you want to understand it, then you should think it this way. DML. First, you have to decode it. What does DML stand for? Data manipulation language. Manipulation. What does manipulation mean? Manipulation is not creation, is adding things, taking away things from the table. So that's insert, update, delete. Okay, so kind of visualize that. I would say create a note card of this, maybe take a screenshot of this on your phone and look at it several times, query yourself to see if you remember, so that in the interview you can answer it on the spot, because it would you would need that. A lot of the interviews are over the phone, so they don't know what you're looking at. Wouldn't it be nice if you had a small sheet of paper with all these important notes written out and you stick it on the wall, and when you pick up the phone for that interview and they ask you that question and you look at that piece of paper and you answer that question? Wouldn't that be nice? Guys, you must do that. Okay, so those are your study things. I'm not gonna give you everything. You have to look at all these PowerPoint slides, take notes, and write things down, because when you hit that interview, you'll be surprised. If you do this now and practice, set up a wall. Okay, my recommendation: set up a corner of your room, put all these things on a wall, and then when you're ready to upload your resume and they call you, you sit right there where you have all your notes on the wall or on a disk or on a piece of paper in front of you. And then when they ask you, go to that section and you answer those questions by looking at it. Once you take like 20 interviews, you'll be like, I don't need to look at that notes anymore. But the first few interviews, I promise you, if you don't have that piece of paper, you're gonna hate yourself for it. Anyway, the other two, this is called data control language, meaning who has control. Also, database admin is going to either grant access you, who will give you access, and he is going to use this command called grant, or revoke your access. I'm not gonna teach you these things or show you in an example, because you will never need it. But they will ask you, what does DCL stand for? Or they might say, what are the commands under DCL? Or data control language. And you're going to say grant and revoke. Done. That's all you need to know. There is nothing else to know about it. It's just a letter, it's just a word. And then they use either to grant access to somebody new or take away their access if they leave the company. And TCL stands for transaction control language. Transaction means every time you write a SQL query is a transaction. Every time you punch your credit card, it's a transaction. Transaction control means every time you write a SQL query, you want to control what happens. Why is that? When somebody tries to drop a table, drop a database or a table, that's a transaction. And your database admin might put some sort of control, meaning you can't just say drop a table and hit enter and it's going to drop a table. It's important data. So they are going to put some control over it, and only time, it depends on where they put the control. If they put control over the drop word and you try to drop a table or delete a table, it's not going to delete it. You think it's going to delete it, but it didn't delete it. It's there, still there. You actually have to go ahead and hit commit. Hit another command called commit and then put a semicolon and hit enter. And then only it's going to execute, because it's going to ask you second time, are you sure? Okay. Now, let's say you committed and you're like, oh my God, I deleted the wrong table. I shouldn't have. That has like the credit card information of my customers. Bummer. Well, no worries. You can use this command called rollback. If you just type the word rollback and put a semicolon and hit enter, immediately everything you did goes back. It's like Control Z for SQL. You guys with me? I don't hear anything.
Yeah, I'm paying attention.
Okay. I don't hear any background noise. There's another thing called save point. Not really needed. You can just say commit and roll back, and that's fine. If they ask you what is data definition language, you're going to say create, drop, alter, truncate. I'll show you later when we do the other. It doesn't support in W3 School. Any questions about this slide?
No, not so far. Just got to study it.
Okay, we're done. I just want to drop you with this formula that you're welcome to use. Haley, what does DQL stand for? Data.
Database query language.
Query. Data. Query.
Language.
Language. Yeah. We've seen the word select. After the select, you have to use the column name, or you can use star. You use the word from. After the from, you use table name. This is to sum it up. After the table name comes where. After the where comes condition. Condition is 3 parts. Who can tell me what 3 parts?
Column name, your what is it called? Like the equals, less than.
Operator.
Operator. And then the last thing is value.
Value. Good job. And these operators, you're welcome to use any one of these. You might want to take a screenshot of this and write it down. And when you go into an interview and your interviewer asks you with a query, you have to take that query and put a piece together into this frame. After the where, you can add group by. This is optional if needed. You just write the column name. If after the group by you need more conditions, you have to say having. And having can only have these aggregate functions. It's not just this 5, there can be more, but nobody will ever ask you anything more than this. And then you put what column name you want to find data of. You can add another, you can add order by towards the end. And then whatever the column name, you don't have to say ascending. Ascending is default or optional. Descending is a must if they want it. And then you limit always goes in the last. If you need to, put the number and semicolon to close, and you're done. This is the frame of data query language that you learned so far. So sum it up and let's move on.
Cool.
Tony, can you tell me what DML stands for?
Data manipulation language.
Correct. Data manipulation language. In data manipulation language, Shobus, can you tell me what commands are part of data manipulation language?
I think it's a insert, update, or delete.
Correct. We got insert into, update, or delete. Okay. Now, even though we just say insert, update, delete, you know that when you write this command, you have to write insert into. Update is just update. Delete, you have to say delete from. Funny thing is, it's not the same as select statement. Select statement, you write the word select and then you write the name of the column. In data manipulation language, insert, update, delete, you have to write table name immediately after that.
Right.
For insert into, if you have to write the table name, and then you have values. You add the values in the parentheses. If it's string, you put it in quotation. If it's a number, you don't put quotation and semicolon to close. Okay, I got it?
Yeah.
If you add all the values all at once, you don't even have to mention which column. But if you don't want to, you can specify how many columns right before the values. And then add the values. For update, it's you say update table name and then you say set. And then you put a condition. Where you want to set it. Column name, and then add the value. You can put a comma in the column name, add a value. You can keep on doing that. And then if you wanted to add a where statement and a condition to close, that will tell you exactly where you need to set the values.
Mm-hmm.
Don't put the where condition, what happens?
Then it'll pull the whole thing. It won't specify anything.
Correct. You are going to change the data of all the data for this column. Everybody is going to become Dallas. Everybody is going to become USA if you don't put a condition. So it's very important that you do that. Delete from, same thing. But instead, you say delete from table, and then you say where there is no other extra word there, but you have to specify condition. And condition is again 3 parts: column name, operator, and a value. That's it, guys. Any questions?
I think you want to show us your work things.
Yeah. Real life example.
Awesome. All right. I'll leave you to it. This is the homework. There's 10 questions only. It's not a lot, but guys, these 10 questions are tough. I have to say, even though it's less, but the front ones are really a lot. It's also posted in Google Classroom, so do it the same way. Due date, I put it as Friday night because Saturday is when I'm gonna grade this. So get it out the way before. You all did it before. I really thank you for that. I'm gonna have the video for you to install. Even though that you're gonna have, you will see there's a Java right here. And under Java, there's installations. Don't do this yet. There is some in here. I need to fix this. This is from the older class. So I will have the video ready for you and the site, and I'll text you all, letting you know when it's ready. Only then start working on it. But all of that work that you have to do, it's going to be your Saturday's classwork, basically. So watch the video, install the Java, and that's just one class for you. It's called installations class on Saturday. Sunday, when you come back to me, it's going to be face-to-face class with me, and I'm going to take you on the first step of Java, and I'll show you how that works.
Cool.
Saturday, if you fail to download what I'm going to, the instructions that I'm going to give you, you call me or text me, and I'll find a time on Saturday to troubleshoot and see if I can figure things out. Don't panic if you get stuck with something and we're not able to fix yours by Sunday, because you're really not going to be using it on Sunday. I might have a homework which might be due next Sunday, so we still have the whole week after to troubleshoot and figure out if you get stuck with that software. But you shouldn't have any issues. All I may have to do is like uninstall a whole bunch of stuff and then reinstall things, and time consuming, but it's doable, and I can clean up your laptop and reconfigure it, so no big deal. Okay, any questions?
No questions.
All right, if no more questions, then thank you so much. Enjoy the rest of your weekend. Really appreciate you being an awesome student and doing your homework. Thank you. Have a good day.
Thank you.
All right, bye-bye.
You don't want to show your work?
What work?
You said you're going to show us something.
Oh, yeah. Did you all want to see that?
And maybe next week, then we can show, you can show us.
Yeah.
It's been a long class already, right?
Yes.
Yeah, let's do that maybe next week.
Okay.
That's
Yeah.
fine. Bye.
All right,
Thank you.
thanks. Bye-bye.